Greetings and welcome, friends. Mr. Waddy here. We're talking about a big idea today, parallel lines. And we're going to be writing equations of parallel lines. But here, before we get there, my friends and I, we did a little exploration, and we discovered that parallel lines have something in common. They have the same slope, So two lines in the same plane that never intersect are called parallel lines. By the way, it is possible to have, imagine if I draw a box. Guys, look at how good your imagination is. Like, you're just imagining it, and it's like I actually drew a box. That's incredible. So it is possible, like this purple line and this purple line are parallel to each other. But it is possible to have two lines that never intersect that are in different planes. I don't know if you guys know that. They are called skew lines. And so like this line and those purple lines would never intersect, but they're definitely not parallel to each other. All right, so parallel lines are in the same plane or surface, okay, and never intersect. Two distinct non-vertical parallel lines are parallel if and only if they have the same slope. Parallel lines have the same slope. And then here's another fact: all vertical lines are parallel. That makes sense. All right, that just makes good sense. So parallel lines have the same slope. So we're going to say M1 equals M2 for our slopes, okay? Is the idea. Es un buen idea. So let's do an analysis of, here's three lines that I'm looking at. Determine which of the lines are parallel. Now, I mean, I could just be kind of like, I don't know, those ones kind of look parallel. But no, let's actually analyze this for real. Let's find the slope of line A. So I'm writing M and then a little subscript A. All right, M sub A. And to find the slope, I'll do rise over run. So this is going down one and over a 1, 2, 3, 4, 5. So the slope of line A is -1/5. You guys agree? Yeah. Let's find the slope of line B. The slope of line B for me. It's going down 1 and over 4. So what do you guys think about lines A and B? Are those parallel? No. No, they are not, because they have different slopes. In fact, if we were to continue them over in this direction, they'd probably hit at some point, right? They'd like intersect over here or something. All right, I don't know, something like that. So those are not parallel. Let's find the slope of line C. I'll have a mixed slope, please. Let's see, down 1 and over 5. Oh my. -1/5. I'm going to say, oh, check this out. I'm going to write new notation for you. A is parallel to C. This symbol, it looks like two absolute value bars next to each other, is the symbol for parallel. Wow. Hooray. And the reason they are parallel is because they have the same slope. Isn't that great? Don't you guys love it? So let's put this to work, friends. Let's put this to work for us. What if, all right, what if when we're like solving our mysteries, right, I'm like, okay, all right, as a detective, I'm like, okay, so you're saying that a line passed through the x coordinate of 5 when the y coordinate was -4 last night? Interesting. And then like you have this witness come up and he's like the twin of the line. He's like, hey, my twin brother, it was him. He went crazy. He's my evil twin. He's tried to kill me before. And you're like, really? He's your twin? How do you guys look similar? Oh, he's got the same slope because we're parallel lines. And you're like, I'm onto this guy. And so like using the fact that it's parallel to this equation and passes through that point, I think we have enough information to find the equation of the line, friends. We're going to get this guy. We're taking him down. I can't wait. Question. Yes. I don't know. Not that I know of. This is, oh, if it's in a drawing, say I had a parallelogram, I could draw arrows like that, and those symbols mean parallel. And then double arrow would mean anything's marked with double arrows are parallel. But no, that's all I know of. I'll have to have you show me later what you're thinking. But here we go. So what is the slope of the good twin? What's his slope? He's in y equals mx plus b. Thoughts? What's his slope? M equals 2. All right, so the slope of the good twin was 2. So what is our culprit's slope going to be? No? Yeah, just plain old 2. He's going to be the same. I mean, you knew he was the evil twin, so you were assuming like negative associated with... Yeah, but yeah, our slope is going to be 2. Now, this line also has a y-intercept of 3, but I don't care about that y-intercept, right? That's the y-intercept of the good twin. I'm going to get my own y-intercept for my own line. I've got to find the line that passes through this point and has that slope. So let's see, this point, if I call x1, that looked too y-ish for me, x1 and y1, how could I find the equation of a line with a slope and a point, or a point and a slope, perhaps a point-slope form? Yeah. So plug in what I know, and I'll have the equation of the line. So I'll have y minus a negative 4, so that becomes plus 4, equals m, which is 2, and x minus 5. So here's the equation. Let's put it in slope-intercept form, just because for fun. So I'll do some distributing. And let's see. So I'll have y plus 4 equals 2x minus 10. And yeah, subtract 4 from both sides. $2x yeah, so I have to distribute. But yeah, one of the things with point slope form is that it's always the opposite of the point's coordinates. Yep. So let's see. So 2x minus 14. So guys, we found our culprit. To show this that it works, let me let's see, y equals 2x plus 3. Let me pull this up here. I'll delete these guys here. So let's see, y equals 2x plus 3. That was the good twin. I also knew that passed through which point? 5, negative 4. I wonder if, I'm assuming this can plot points. Oh, cool. It even like is showing me this is going to be a graph. This is going to be a point. Let's plot this point. Can I? Oh, there's my point. Okay. So I've got a line and a point, and we wanted to find the equation that was parallel to that line that passed through said point. Let's see. Let me zoom in. And we said y equals 2x minus 14. Bam! We got him! Look at that. Wow. That was an amazing shot. Did you see that? It's parallel to the red line and passes through the point. Mystery solved, friends. We solved that mystery. So yeah, so that just done works. That just done works. Let's do problem 2 from the monitoring progress. I think I gave you guys this problem. Same type of problem. Let's see if we can figure this out. All right. So write an equation of a line that passes through negative 4, 2 and is parallel to this one. Let me open it up on the graph again. Let's see. I'll get rid of this one and this one. Let's see. So so negative 4, 2, negative 4. No, what am I doing? Comma 2. Oh dear. Is that negative? That is not negative. Ah! There we go. All right, there's negative 4, 2. Plotted the point. Oh, it's red this time. And the line is y equals 1/4 x plus 1. All right, so y equals 1/4 x plus 1. All right, so I'm expecting, I'm looking for a line that is parallel to this green one that passes through that red point. All right, so you might be able to like visualize exactly what that looks like. But in order to do that, my line is going to have the same slope as their line. Do you think it's going to have the same y-intercept as their line? A line that's parallel to that green line? No, it's probably going to have a y-intercept somewhere around here, right? Yeah, so it's definitely not going to have the same y-intercept, but I do want the same slope. So what is the slope of their line? 1/4. So I'll call it slope 1 equals 1/4, or up 1 over 4. And what is our slope going to be? Our slope is going to be the same as their slope. All right? Our slope is going to be the same as their slope. Now, I'm not interested in their y-intercept, right? I just wanted to use the slope, right? Because my y-intercept is definitely going to be different than that one. So I don't care about the y-intercept. I just want the slope. And I know a point that it passes through. So there's x1, y1. And now we'll just plug it in to point slope form. Here we go. Y minus 2, because 2 is y1, equals m, which is 1/4, parentheses x minus x1. X minus a negative 4 is plus 4. Careful of those opposites, friends. And let's distribute this. So I'd have a quarter x plus, what's a quarter of 4? Or what's 4 divided by 4? 4 divided by 4. That's 4 times 4. 4 divided by 4. It's just regular old 1. Yeah. And how do I get y by itself? Add 2. So here's our line. I think we found it. Y equals 1/4 x plus 3. Let's graph it. That is actually the y-intercept that we predicted earlier as well. All right. Y equals 1/4 x plus 3. Bam! Nailed it. You see that? Hit the point. Backboard, right, from across the gym. So great. It's amazing. So we can now find equations of lines with additional clues, right? And when I know that it's parallel to another line, it's going to have the same slope, and it should have a different y-intercept. Otherwise, it's not going to be parallel. Because, right, if this had the same y-intercept, notice it would just be the same line, right? But that's not helpful. That just wouldn't be helpful. Okay. Well, I think that's all I'm going to do for today, because tomorrow we're going to hit perpendicular lines. Oh, tune in for that episode, friends. Thanks for watching. Have a great day.